Hi students, in this video we shall discuss some properties of triangle. So now whenever you consider a triangle, so it has three sides, right? Three sides, AB, BC and CA or AC, as well as three angles, angle A, angle B, angle C. Now suppose if any two sides of a triangle are equal in length, that means if this length is 5 meter and this is also 5 meter, then this triangle is called isosceles triangle. Isosceles triangle. Okay, so a triangle which has two sides, in which two sides are equal, is called an isosceles triangle. This side may have different measure. Okay, so if all three sides are equal, then it is called equivalent triangle. Now the property of isosceles triangle is, so two sides are equal. So if two sides are equal and if you measure these two angles using protractor, then these two angles will be same, which are opposite to same side. So therefore we have the theorem that angles opposite to equal sides of an isosceles triangle are equal. If these two are equal, then the opposite angle and these two opposite angle, right? So these two angles will be equal. So 60, if this is 60, then this angle is also 60. Let us see the theorem. Okay, the theorem says that angles opposite to equal sides of an isosceles triangle are equal, right? So let us draw the isosceles. So here is an isosceles triangle with vertices A, B and C. So what is given here? And equal sides, right? AB equal to AC, given AB equal to AC. What we have to prove? Angles opposite to those equal sides of an isosceles triangle are equal. We have to prove that these two angles are equal. That is, to prove angle B is equal to angle C. These two angles are equal. So that is the statement of theorem. We have to prove these two angles are equal, opposite to equal sides. Okay, let us see the proof. Now let us make some construction here. Construction. Okay. So I will divide angle A into equal half. Okay. So that is angle bisector AD. So we have to write here, draw angle bisector AD, okay, and join 1 and 2 BC. So this is the construction. Draw angle bisector AD to the angle A. Okay, so to the angle A, this is 60 degree, then 30. So that is the meaning of angle bisector. So now from triangle, so this angle bisector divides triangle ABC into two triangles, that is ADB and ADC, right? So we will prove that these two triangles are congruent. From triangle ADB and triangle ADC, so two triangle ADB and ADC, it is not 90 degree, okay, not necessarily 90 degree. So from these two triangles you can see that from ADB and ADC, AB is equal to AC. So it is given, okay. So given that two sides are equal, so therefore, so they are sides of different angles considering ADB and ADC, therefore they are equal. And also angle BAD is equal to angle CAD. Angle BAD is equal to CAD. Okay. So because angle bisector construction. Because construction. Next you can see that AD is common to both the triangles. AD is equal to AD because common side. So therefore side angle side using Sas Congruence Rule. Therefore by Sas Congruence Rule, what we can say that these two triangles, triangle ADB congruent to triangle So therefore, so if you see these two triangles, so these two angles are corresponding angles. So definitely these two angles will be corresponding angles, and these two angles will be corresponding angles. So therefore these two are congruent. We can say that using CPCT, corresponding parts of congruent triangle, these two angles will be equal. Angle ABD must be equal to angle ACD. Therefore angle ABD must be equal to angle ACD, because CPCT, congruent, corresponding parts of congruent triangle. So which implies angle B is equal to angle C. So angle ABD is equal to ABD is same as angle B. Okay. Similarly, angle ACD is same as angle C. That's it. So that is why we have written angle B is equal to angle C. So that is what we have to prove. An important theorem. Okay, in the previous theorem we proved that if two sides are equal, then angles opposite to those two sides are always equal. Now suppose if you consider any triangle, okay, if you consider any triangle, so without knowing the measurement of sides, if you know that any two angles are equal in the triangle, if any two angles are equal, if this is 60, this is 60, then sides opposite to those two angles are always equal. If this angle B is equal to angle C, then side opposite to angle B, that is AC, is equal to side opposite to angle C, that is AB. Okay, so therefore these two sides will be equal. So this theorem is nothing but converse of the previous theorem. Okay, in a triangle, if two angles are equal, then sides opposite to those two angles are always equal. Okay, you can write down this statement in your notebook. The sides opposite to equal angles of a triangle are equal. Okay, we shall discuss exercise 5.2. First problem. In an isosceles triangle ABC with AB is equal to AC, the bisectors of angle B and angle C intersect each other at O. Join A at O. Show that OB is equal to OC. AO bisects A. So the question is, in an isosceles triangle ABC, let us draw an isosceles triangle ABC. So triangle ABC with AB is equal to AC. AB is equal to AC. The bisectors of angle B, bisector of angle B, so a line, and bisector of angle C intersect each other at O. Okay, like this. So this is point O. Bisector of OB is bisector of angle B, and OC is bisector of angle C. Okay, intersect each other at O. Join A at O. Join like this. Show that OB is equal to OC. OB is equal to OC. We have to prove that OB and OC are equal. Also, AO bisects angle A. AO or OA bisects angle A. Okay, first we will write what is given. Given AB is equal to AC. So it is given AB is equal to AC. So we know that in an isosceles triangle, two sides will be equal. So therefore angles opposite to those two sides, angle opposite to AB is angle C, that is ACB, this angle, and angle opposite to AC is ABC. So therefore angle B and angle C are equal. So which implies angle ACB is equal to angle ABC. Okay, so since AB is equal to AC, using theorem, and then it's given that ACB is equal to ABC. These two angles are equal, that means 60-60. If OB is bisector, then these two angles become 30-30. Since B and C are 60-60, so I am considering a particular example, so it is not necessarily 60 degree. Okay, So 30 30, it is also 30 30. So therefore these two angles become equal, 30 30. Okay, because OB is bisector, OC is also bisector, and these two angles are equal. So therefore we can say that angle OBC is equal to OCB. Okay, so therefore angle OBC is equal to angle OCB, because OB and OC are angle bisectors. Okay, so which implies, so now if you consider triangle OBC, now angle OBC and OCB are equal, these two angles are equal, and from the converse theorem that we just proved, so from the converse theorem what we can say, that in a triangle if two angles are equal, then sides opposite to those two angles, so these two angles are equal, so here it is because of angle bisector, so therefore opposite sides are OB and opposite to this angle OC, these two sides are equal, so that means OB is equal to OC. So that is how we can prove first result, OB is equal to OC. Now in order to prove AO bisects angle A, so we have to prove that these two angles are equal, so then we can say that AO line bisects angle A. So to show that these two angles are equal, so let us consider these two triangles and show that those two are congruent. Okay, so now from triangle ABO and triangle ACO, from these two triangles ABO and ACO, these two triangles, AB is equal to AC, because given, it is given that isosceles triangle with sides AB is equal to AC, given. Okay, so then next we can see that OB is equal to OC, we have proved. Okay, so that is OB is equal to OC. OB belongs to first triangle, OC belongs to second triangle. Okay, so result 1 we can say. Okay, so this is result 1. Then so these two sides are equal, okay, corresponding sides, and this angle, so since these two angles are equal, we have proved here. Okay, so then, and OB and OC are bisectors, so these two angles must be equal, that is angle ABO is equal to angle ACO, because of OB and OC are angle bisectors. Okay, so therefore by, so side, angle, side. Okay, so two sides and included angle, so therefore by Sas Congruence Rule, what we can say, triangle ABO congruent to triangle ACO, so these two triangles are congruent. So therefore we can say that using CPCT, angle BAO is equal to angle CAO. Okay, BAO is equal to CAO, so those two are nothing but the angles, angle A divided into two angles. Okay, so these two angles, because CPCT, therefore we can say that AO bisects angle A. Okay, so these two angles are equal, that means AO bisects angle A. So that is second result. Second problem, in triangle ABC, AD is the perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle in which AB is equal to AC. So here is the diagram. So triangle ABC, AD is perpendicular bisector of BC. So AD is perpendicular, that means 90 degree, and bisector of BC. Bisector of BC means it divides BC into equal half, BD equal to DC. So that is the meaning of bisector. Okay, equal, if it is 10 meters, then BD is 5, DC is 5 meter. So and per 90 degree. Okay, show that triangle ABC is an isosceles triangle. We have to prove that ABC is isosceles triangle with AB is equal to AC. So isosceles triangle means two sides will be equal or two angles. So we have to show that it is isosceles triangle with AB is equal to AC. Okay. So solution. So what is given? We'll write given things. That is AD is perpendicular to BC. AD is perpendicular to BC and BD is equal to DC. These two are given. Bisector means so BD is equal to CD or DC, whatever you can write. Okay. So next, what we have to prove? So we have to show that ABC is an isosceles triangle. So now, with side AB is equal to AC. So now you can see here AD divides ABC, a triangle, into two triangles. That is triangle ADB and triangle ADC. To prove that AB is equal to AC, let us show that ADB and triangle ADC are equivalent triangle. So using that concept we can show that AB is equal to AC. Okay. So from triangle ADB and triangle ADC, so what is equal here? You can see that AD is equal to AD, which is common to both. Common. Okay. So AD is common and angle ADB is equal to angle ADC because 90 degree. Okay. And BD is equal to CD. BD is equal to CD because given angle bisector. Okay. BD is equal to CD given. So therefore side angle side. So therefore by Sas Congruence Rule, triangle ADB equivalent to congruent to triangle ADC. So these two triangles are congruent. So therefore using CPCT we can say that AB is equal to AC. So therefore AB is equal to AC because CPCT. Okay. So this is how we can say that. So AB is equal to AC means considering triangle ABC, ABC will be isosceles triangle. Okay. So which implies triangle ABC is an isosceles triangle. Isosceles triangle. Next problem. ABC is a triangle in which altitude BE and CF, two sides AC and AB are equal. Show that triangle ABE congruent to triangle ACF. Second one, AB is equal to AC, that is ABC is an isosceles triangle. So now ABC is a triangle, okay, in which altitudes BE and CF, BE and CF are altitudes to the sides AC and AB. So to the sides AC and AB, okay, altitudes are equal. That means here AC and AB are not equal. Okay, given that BE and CF are equal, so these two are equal, altitudes are equal. We have to show that triangle ABE, so this triangle ABE congruent to ACF, so this triangle. Okay, so solution. So first we will write given things. What is given? BE equal to CF. Okay. So first proof. So we have to show that triangle AB congruent to triangle ACF. So from triangle ABE and triangle ACF, we will consider those two triangles. So what are equals? We will see. So first we will write given things. So BE is equal to CF. Okay, BE belongs to first triangle, CF belongs to second triangle. Those two are equal because given. Okay, altitudes. And angle BEA is equal to angle CFA. Okay. Angle BEA is equal to angle CFA. Those two are because 90 degree. Okay, those two angles. Then you can see here A is common to both the triangles. you can see that angle BAE is equal to angle CAF. Okay, BAE in the first triangle, CAF in the second triangle, but both angles are equal because they are common. So therefore, two angles and one side. So using ASA congruence rule. Therefore, by ASA congruence rule, what we can say, triangle ABE congruent to triangle ACF. These two triangles are congruent. So therefore, using CPCT, we can say that AB is equal to AC. AB is equal to AC because CPCT. AB is side belongs to first triangle, AC belongs to second triangle. Okay, so that is the proof for second one. So which implies ABC is an isosceles triangle. So this is how you prove or solve the problem. Next problem, ABC and DBC are two isosceles triangles on the same base BC. Show that angle ABD is equal to angle ACD. So given that ABC and DBC are isosceles triangles, so here mark they have given. So BD is equal to DC. These two are equal. Similarly, AB is equal to AC. So the mark they have been given here. Okay. So AC is equal to AB. So what we have to prove? Show that angle ABD is equal to ACD. These two angles, we have to show that these two angles are equal. Okay. So we'll write given things. So what is given? AB is equal to AC and BD is equal to CD. So show that angle ABD is equal to angle ACD. So now AB is equal to AC, which is given. Okay, AB is equal to AC, which is given, which implies, so ABC is isosceles triangle. Two sides are equal. If two sides are equal, then angles opposite to those two sides. Angle opposite to AB is this angle, that is ACB, and angle opposite to this side, so that is ABC. These two angles will be equal. Angle ACB must be equal to angle ABC. These two angles are equal. Okay, so because you can write the reason, because angles opposite to equal sides. Similarly, what we can write using triangle BD is equal to CD given. BD is equal to CD is given. That implies angle BCD is equal to angle CBD. These two angles opposite to sides. Okay, so because angles opposite to equal sides. So let me consider it as equation 1 and this as equation 2. Adding 1 and 2. What we get? Adding 1 and 2 means adding left hand side. Angle ACB plus angle BCD. So BCD I will not consider like that because we should get these two angles, sum of these two angles. So here ACB is plus BCD. Okay, no problem. BCD. So same side. That is equal to angle ABC plus angle CBD. Okay. So angle ACB plus ACB plus BCD. These two angles. Sum of these two angles is nothing but ACD. That is equal to angle ABC plus CBD. these two angles is equal to ABD, right? So ACD is equal to ABD, ACD is equal to ABD. That is what we have to prove.